Hi, in this lesson we are going to see f of x is equal to x over square root of x squared plus 1. Sketching the curve with the 7 guidelines. Okay, first guidelines, it is a what is a domain? What is a domain? It has the fraction. Okay, denominator should not be 0. Here denominator square root of x squared plus 1 cannot be 0 because x squared is positive plus 1 is also positive. So denominator will not be 0. So there is no restriction in the domain in case of the denominator. And another restriction is square root. Square root should be positive. Okay, that is also positive because x squared is always positive. Square root, you understand? X squared is always positive. Okay, and plus 1 is also positive. So what is this? It has no restriction on the square root also. So domain is real number, all the real numbers. Okay, actually if there is denominator, there will be in general, for example, x by x plus 2 means x is not equal to minus 2, one problem will come. Okay, that is and another one case, suppose x over x plus 1 means also square root should be always positive. So what the value will come, x should be x plus 1 is greater than 0, so x is greater than minus 1, like that will come. But here due to the denominator is square root of x squared plus 1, we have no issues. Okay, so domain is all real number. Second is x intercept, y intercept. X intercept, y intercept, how to find out? To find the x intercept, y intercept, put x is equal to 0 to find the y intercept. X is equal to 0 means it will be 0 only. Okay, and put y intercept, x is equal to 0 means y equal to 0. For x intercept, y equal to 0 means 0 equal to x over square root of x squared plus 1. So x is equal to 0. So from this what we concluded, from these 2 points, this will be any number from minus infinity to plus infinity, the curve will go. And another one thing, the curve will pass, x intercept is x is equal to 0, y intercept is y equal to 0. The curve can be like this, the curve can be like this, because it is crossing at only one place. So either this one or that one. From this 2 point we understand. Okay, from this 2 point we understand. Now we will go step by step, then whether the curve is increasing, concavity up or down, where is the local maximum, where is local minimum, we will see it. It cannot be local maximum. Let us see one by one. Okay, question number, third step is symmetry. Symmetry is what? You replace x with minus x. Okay, so what will happen? F of minus x is equal to f of minus x equal to, just replace it. In general, if it is okay, first I will f of minus x is equal to, instead of x I put minus x. Here also you put the same, minus x over square root of minus x whole squared plus 1. So what will happen? Minus x whole squared will be x squared only. So x squared plus 1. So what happens? It is f of minus x is equal to minus f of x. So it is odd function. We got another one clue from the step number 3. What clue we got it? It is odd function. It is symmetry about the origin. One good point is, suppose the curve is like this, means it is easy to find left hand side. just rotate about 180 degree. Okay, from this 3 point we understand the domain is complete, minus infinity to plus infinity, and from the intercept we come to know either like this or like this, and the third one is it is a odd function, so it is symmetry about the origin. Okay, whatever. Fourth is another important point. Can you note it down? These 3 points, note it down. Fourth is asymptote. Asymptote, if it is vertical asymptote, if the domain has any restriction, then domain, suppose domain is x is not equal to 1, means vertical asymptote will be x is equal to 1. Here domain has no issues, so there won't be any vertical asymptote. What is the horizontal asymptote? Horizontal asymptote, when f of x is going to be the infinitive, when f of x is going to be the infinitive, it becomes, when x is going to be the infinitive, f of x becomes one value, L. When x is to infinity, f of x tends to goes to one value, L. For example, instead of x is infinity, over infinity square is also infinitive, that if you square root also infinitive. So infinity by infinity, it is 1. Okay, so y asymptote, horizontal asymptote is y equal to 1. Horizontal asymptote, another rule is when x is going to be the minus infinity, what the f of x will become? Minus infinity over x squared is minus infinity square. So it is plus infinity square. It is if you take square root, it will be minus infinity over infinity. So it will be minus 1. So there are two asymptotes. Okay, y equal to 1, y equal to minus 1. I repeat the rules. When x is going to the infinitive, if f of x becomes L, that is horizontal asymptote. Second, when x is going to be negative infinitive, then f of x becomes L, that is also horizontal asymptote. So here we did it. Another simple way we are doing to find the horizontal asymptote, we are taking the highest coefficient of, for example, 2x squared plus 3 over x squared minus 4x, like that is the fashion. We are taking the highest coefficient, 2x squared by 2, it will become 2x squared by x squared, it will become 2. So horizontal asymptote is 2, one simple rule. But here, the highest coefficient is, the highest degree is x power 1 or only. Here also x power 1 only. Actually it is x squared, but square root of x squared is x power 1 only. So x by square root of x squared will be 1. Since it is a square root, if you remove it, 1 by plus or minus 1, so it will become plus 1 or minus 1. I hope this is a simple technique, but you follow the rule. When x is infinity, f of x becomes L, that is the horizontal asymptote. When x is minus infinity, f of x becomes L, that is also horizontal asymptote. Okay, so we found horizontal asymptote y equal to 1 and y equal to minus 1. So from that we concluded from the above 4 point, it is domain is all the numbers, and you see it is passing through the origin either like this or like this. We will come to know from the step number 5, and it is no symmetry. And the fourth is it is y equal to 1 y equal to minus 1. We got it. Okay. So there is, okay, now fifth. I already worked on. Fifth is intervals. How to find the intervals? Intervals is when f dash x is greater than 0, it is increasing. When f dash x is less than 0, it is decreasing. Okay, now f dash x is, I differentiate. U over v means we know that v, u dash minus u, v dash by v squared. Okay, so denominator I keep as it is, square root of x squared plus 1. Numerator if I differentiate 1 minus, numerator I keep as it is, I am differentiating, it is x squared plus 1 half is half times x squared plus 1 power minus of, then x squared, again I am differentiating, it is 2x. Okay, this and this will cancel. So what will become? What will become? Okay, then denominator is square root of x squared plus 1 square. Okay, square root of x squared plus 1, I multiplied, this 2 will cancel, again x squared minus x squared over, this minus of will come here, square root of x squared plus 1. Okay, by denominator, square root of and square will cancel, so x squared plus 1. Make it LCM, this one. If you do it, x squared plus 1 minus x squared over square root of x squared plus 1. Okay, denominator again x squared plus 1, that you can make it x squared plus 1 power 3 by 2. Okay, x squared minus x squared, it will be cancelled, equal to 1 over x squared plus 1 power 3 by 2. Okay, now very simple. Okay, this is f dash x. You equate it to equal to 0. F dash x is equal to 0 means what? Always x squared is positive, plus 1 is positive, power 3 by 2 is also positive. So x squared plus 1 power 3 by 2 will lead to the positive only. Power 3 by 2 is not the positive, but x squared plus 1 is positive. So this is always increasing. Always increasing means f dash x is greater than 0. So it is from minus infinity to plus infinity, it is increasing. So now I can draw the line like this. Okay, now there is no local maximum minimum. Step number 6, local maximum minimum, because f dash x cannot be 0. So step number 6 is also finished. Now we have only one pending, concavity up or down or point of inflection. Okay, concavity, because we understand either like this or like this, we don't know. So for that we are going to do f2 dash x. f2 dash x is 1 over, kindly note it down. Kindly note it down. Okay, note it down. Now come here. f2 dash x. This f dash x is x squared plus 1 power minus 3 by 2. If you take it out of, then f2 dash is minus 3 by 2, x squared plus 1 minus 3 by 2 minus 1 is minus 5 by 2. X squared plus 1, if you differentiate, it is 2x. Okay, what will happen? Minus 3 x squared plus 1 power minus 5 by 2. Okay, this f dash x, what will happen? Minus 3x over x squared plus 1 power 5 by 2. When it is negative, when whatever it be the case, denominator will be positive only because of x squared plus 1. In the numerator, minus 3x is there. So when x is less than 0, it is positive. When x is less than 0, it is positive. How? Already minus sign is there. So minus infinity to infinity 0, it is positive. And when x is greater than 0, it is negative. 0 to infinity, it is negative. Okay. So now I can draw the curve. I can draw the curve with all the details. Now we got all the details. The curve is domain, all the real numbers. Second is it is passing through the x-intercept, y-intercept is origin. Third is it is what is called odd function. So it is symmetry about the origin. If you know the right hand side, you can do the left hand side by rotating about 180 degree. Fourth is horizontal symmetry is at y equal to 1 and minus 1. Fifth step is intervals of increase. It is minus infinity to plus infinity, it is increasing. So the curve is going like this. Sixth is there is no local maximum minimum. Okay. Seventh is it is concavity up, minus infinity to 0. This is called concavity up. This is called concavity down. Okay. Concavity up and 0 to infinity, it is 0 to infinity, it is concavity down. So we did all these things. Thank you for watching my YouTube videos. Please note it down. Please watch my other videos related to sketching the curve. I am making around 10 examples. I have already did 3 videos. This is my 4th video illustrating the sketching the curve, and I am making 7 videos for the each guidelines. How to make, how to find the domain, how to find the intercept. Each guideline also I am separately I have separately made that videos also. Watch, it will be very useful. Those who are viewers already commenting about it. Thank you for watching. See you.